Work and energy. Forms of energy: kinetic energy, potential energy, gravitational potential energy, law of conservation of energy, rate of work. Forms of energy: kinetic energy. A moving object can do work. An object moving faster can do more work. Kinetic energy is the energy possessed by an object due to its motion. The kinetic energy of an object increases with its speed. The amount of kinetic energy of a moving body depends on mass of body, kilograms, velocity, ms raised to power minus 1. And formula of kinetic energy is kinetic energy is equal to half of mass into v square. As mass doubles, kinetic energy doubles. As velocity doubles, kinetic energy increases by 4 times. When either mass or velocity of moving body is increased, kinetic energy will also increase. Potential energy. Take a rubber band, hold it at one end and pull from the other. The band stretches. Release the band at one of the ends. What happens? The band will tend to regain its original length. Obviously, the band had acquired energy in its stretched position. How did it acquire energy when stretched? You transfer energy when you stretch a rubber band. The energy transferred to the band is its potential energy. In the above situation, the energy gets stored due to the work done on the object. The energy transferred to an object is stored as potential energy if it is not used to cause a change in the velocity or speed of the object. The potential energy possessed by the object is the energy present in it by virtue of its position or configuration. Potential energy of an object at a height. An object increases its energy when raised through a height. This is because work is done on it against gravity while it is being raised. The energy present in such an object is the gravitational potential energy. Gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against gravity. Gravitational potential energy can be calculated with GPE is equal to mass into gravitational acceleration into height above ground level. The SI units of gravitational potential energy is joule. Law of conservation of energy. Energy cannot be created nor destroyed. This is the law of conservation of energy. Conservation of energy is the term used to denote change in energy from one form to another. Burning candle chemical energy to heat and light. Fuel, from chemical energy to heat to kinetic energy into electricity. Nuclear explosion, nuclear energy to heat and light. Spring, elastic potential energy to kinetic energy. Let an object of mass m be made to fall freely from height h. At the start, the potential energy is mgh and kinetic energy is 0. Why is the kinetic energy 0? It is 0 because its velocity is 0. Therefore, total energy of the object is thus mgh. As it starts falling, its potential energy will change into kinetic energy. If v is the velocity of the object at a given instant, the kinetic energy would be half mv square. As the fall of the object continues, the potential energy would decrease while the kinetic energy would increase. When the object is about to reach the ground, h is equal to 0 and v will be the highest. Therefore, the kinetic energy would be the largest and potential energy the least. The sum of the potential energy and kinetic energy of the object would be the same at all points. That is, potential energy plus kinetic energy is equal to constant, that is mgh, plus half mv square is equal to constant. The sum of kinetic energy and potential energy of an object is its total mechanical energy. We find that during the free fall of the object, the decrease in potential energy at any point in its path appears as an equal amount of increase in kinetic energy. There is thus a continual transformation of gravitational potential energy into kinetic energy. Rate of doing work. Do all of us work at the same rate? Do machines consume or transform energy at the same rate? No, because everyone has not same ability or capability to do same work with same rate. Power is defined as the rate of doing work or the rate of transfer of energy. If an agent does a work W in time T, then power is given by power is equal to work divided by time. P is equal to W upon time. The unit of power is watt. 1 watt is the power of an agent, which does work at the rate of 1 joule per second. We can also say that power is 1 watt when the rate of consumption of energy is 1 joule into s raised to power minus 1.
What is 1 kilowatt hours? Let us say we have a machine that uses 1000 joule of energy every second. If this machine is used continuously for 1 hour, it will consume 1 kilowatt hour of energy. Thus 1 kilowatt hour is the energy used in 1 hour at the rate of 1000 joules per second or 1 kilowatt. 1 kilowatt hour equals to 1 kilowatt into 1 hour equals to 1000 watt into 3600 seconds equals to 36 lakh joules. 1 kilowatt hours equals to 3.6 into 10 raised to power 6 joules.
Electrical energy is expressed in terms of units. Here, 1 unit means 1 kilowatt hour. Summary. Work done on an object is defined as the magnitude of the force multiplied by the distance moved by the object in the direction of the applied force. The unit of work is joule. 1 joule is equal to 1 Newton into 1 meter. Work done on an object by a force would be zero if the displacement of the object is zero. An object having capability to do work is said to possess energy. Energy has the same unit as that of work. It's all about this subtopic.